Okay, so now we're working on part 2 here. So if f of x is equal to sine x, we're going to show that f of x plus h minus f of x over h equals sine x cosine h minus 1 over h plus cosine x sine h over h. So we're going to start with our left-hand side, and we are going to show that we're going to start by plugging in. So we've got f of x plus h minus f of x over h. So this will equal sine x times x plus h minus sine x all over h. So sine x of x plus h, we're using our addition formula there. So that'll get us sine x cosine h plus cosine x sine h. So this is our s and our t. So we're using sine x, s plus t. And then we bring down our minus sine x all over h. Well, this equals the sine. I'm going to factor out. I've got sine x cosine h, and I've got sine x. So sine x times cosine h minus 1 plus our cosine x sine h all over h. We can start to see how it's coming together. We've got the sine x, we've got cosine h minus 1. Over here we have cosine x and we have sine h. But the difference is it's split apart. So what we can do is we can take each part of our fraction by splitting it in the middle with the plus sign and put it over our h. So that'll get us sine x times cosine h minus 1 over h plus cosine x times sine h over h. And because it's multiplication, it's okay if we just have the h under part of our fraction. And this matches what we have up here. So for the next problem, we are evaluating an expression involving trig functions. So we're going to evaluate sine of theta plus phi. And this will be where sine theta equals 12 over 13 and theta is in quadrant 2. Remember, our quadrants help us know our signs. And we have tangent of phi is equal to 3/4 and phi is in quadrant 3. So for our solution on this, we are going to kind of sketch what we know about our values here. So to sketch the angles, we're going to use our standard position with our terminal sides in the correct quadrant. So when we look at the first one, so let's draw a triangle over here. So we've got our quadrant. We are in quadrant 2. We have sine theta, which is 12 over 13. Well, let's talk about what sine theta is. So sine theta is y over r. So that means if it equals 12 over 13, then our y value is 12, and the r, which is the radius, is 13. All right, so we've got the y value of 12 and the radius of 13. So somewhere up here we've got a value of 12, and we'll have our radius going out at 13. And we still need to find our x value. Well, to find the x value, we can use the Pythagorean Theorem. So if we have x squared plus y squared will be equal to r squared. So we've got x squared plus 12 squared equals 13 squared. So x squared plus 144 is equal to 169. Subtract our 144 over. We get x squared is equal to 25. Taking the square root of both sides, we get x is equal to plus or minus 5. Well, what quadrant are we in? We're in quadrant 2. So quadrant 2 makes x negative. So quadrant 2, x will be equal to negative 5. So that means we're hitting a value of negative 5 for our x. So whether or not we measure our y value on the axis or if we draw the triangle over there, it doesn't matter, as long as we have what we need going on there. Alrighty, so we've got an angle of theta happening here, and we've got our triangle all set up. Now we also have our tangent that we need to take care of. So let's go ahead and draw the tangent 1. All right. So for tangent, we have tangent of phi is equal to, well, tangent itself is equal to y over x, and this will equal 3/4. So that tells us our y value is 3 and our x value is 4. So we still need to find, in this case, we'll still need our radius. So let's go ahead and draw our picture. So our y value is 3 and our x value is 4, but we know we're in quadrant 3, so we know actually they're both negative. So the x value will be over here at negative 4, and the y value will be down here at negative 3. So what we're trying to figure out then is, what is our radius? So this will be negative 3. So we're going to use our Pythagorean theorem again. We've got x squared plus y squared is equal to r squared. So 4 squared plus 3 squared is equal to r squared. So that gets us 16 plus 9 is equal to r squared. So 25 will equal r squared. Taking the square root of both sides, we get 5 is equal to r. Now, why is this one not plus or minus? Because the radius is a distance, and distance is not negative. So that tells us we've got 5 as our value there. Well, we want to find the sine of theta plus phi. So you may be wondering, well, why did we have to do all of this? Well, the reason we have to do all that we just did is because we needed more than what we had. We were given a tangent, but that doesn't put it in terms that we can completely use because we need more of the values that we had. And to find some of the other parts that we needed, like cosine, in order to do our addition type configurations, we need not just sine, but we also need the cosine values. So we needed to be able to find the x value, and we needed our r value for our phi. So let's go ahead and see if we can finish figuring out and solving this problem. All right, I'm going to scooch that up a little bit. So we're going to take the values that we have and we're going to expound on those. All right, so to find our theta plus phi, we're going to use the formula for sine, or the addition formula. So we're using the addition formula for sine. So, whoops, and I forgot the sine part there. So we've got sine of theta plus phi will be equal to sine theta cosine of phi plus cosine of theta sine of phi. That's the formula that you'll find in the book. So what is the sine of theta? Well, the sine of theta was given to us, so that'll be 12 over 13. And the cosine of theta, well, we need to figure that one out, right? So cosine is equal to x over r. So our x value for our theta is going to be negative 5, right? X over r. No, I look at the right one here. So x value is negative 5, and that's why, because I'm looking at the wrong one. Okay, sorry about that. So it's phi that I'm looking for. I'm like, why does this sign when the value's not working? All right, so we've got the x value is 4, and the r value is 5. So it's going to be 4 over 5. But is it positive or is it negative? We're in quadrant 3, so it will be negative. Plus, we need the cosine of theta, which is going to be our x value of negative 5 over our r, which is 13, times the sine of theta, and the sine of theta, sine of phi. So sine is going to be equal to y over r. Our y value is 3, and our r value is 5, but we're in quadrant 3, so it's negative. So this will get us negative 48 over 60, and this will be a negative times a negative, which will get us positive. 5 times 3 is 15, 13 times 5 is 60. Well, negative 48 plus 15 will get us negative 33 over 65. And that will be the value of sine theta plus phi.